So here I am talking about climate to a room full of experts, and that's always a little bit intimidating. What I will try to do, however, is concentrate on things that you may not know, assuming you know a lot. And I'll repeat some things. A lot of you will know a lot of these things. I'm not going to be talking very much about biofuels in this forum, although I will mention them. But what I try to do is maintain the broad overview and understand sort of, I like to be in a room full of experts in different fields, I like to be second most expert on every subject. That's a nice challenge, something I aspire to do, and I'm still working at it. I'm going to try to give you a broad overview of what's going on in climate change, because there's a lot happening, and most of it's confusing, and if it's not right in your field of expertise, you could easily be confused. So let me begin simply by clarifying something that you understand, but the general public often doesn't, and that is when talking about climate and energy, there are two major national security issues for the United States and indeed for the world. I call them climate change and energy security, and they are often confounded. Certain things like biofuels address both issues. Other things, such as the oil sands of Canada, address one issue but not the other. Other things such as, there are other things that address both, like energy conservation. But I find the public often gets these confused, and politicians, sometimes I sense they confuse them on purpose. You get one politician and you ask them about climate change, and before you know it, they're talking about energy security. You can guess which party that is. There are other political parties that will flip it the other way around. So I'll try to be clear and keep those issues separate. The energy security issue is actually, I like to call it liquid energy security, because we have lots of natural gas, we have lots of coal in the United States. What we're short of is liquid energy. And this is a plot, you've seen things like this, different countries and how much barrels of oil equivalent they have. I'll be showing this plot again later. And here's the US, and there's Saudi Arabia. And a lot of people, you probably know this, but a lot of people around the country have no idea what country comes in second, and there it is, Canada. I'll come back to this, but this is the liquid energy security, something that Energy Biosciences Institute is directly addressing, in addition to the issue of climate change. And people need to recognize that. Here's an issue, though, that doesn't get much attention, and people tell me I shouldn't be saying it even. This is a plot that I'll be talking about a little bit later in more detail that was in an op-ed piece that I wrote for the Wall Street Journal last December. And what it shows is the coming carbon dioxide from around the world. Now, up until 2010, this actually goes to 2007, these curves are all based on the Energy Information Agency. Then what I've done is extrapolated the expectation based on the proposed Copenhagen Treaty, which was not signed. So if we assume that the US was going to cut its emissions by 80%, there we are. These are the US emissions. If we assume that China and the developing world were going to reduce their emission intensity, which means they would grow at a rate of 6% per year carbon increase rather than 10%, then these are the emissions from the developing world. And I'll be coming back to this plot and discussing it more. This is a plot that I've been told you shouldn't even show this because it will insult the Chinese and they'll never sign a treaty. What it indicates to me is that anything we do in the United States that is not readily adopted in China, India, and the developing world is almost worthless. That is, the United States, our emissions, here they are going down 80%. If they didn't go down 80%, they'd be there. They went up, if they doubled, they'd be there. But some people dispute this. They say China cannot continue to grow their economy at 10% per year. Okay, they did 9% during the recession. But 10%, they cannot do that. It's a bubble. It doesn't go on forever. I say it's not a bubble because China exists in an existing world. By the way, there are two seats right down here and some over there if you want. If you want to sit in the front, then I can tell if you're falling asleep. Otherwise, you can go to the back and I'll still notice anyway, I guarantee. I might even wake you up. I do that in my class from time to time. This is an issue that people in Washington know about. They don't like to talk about. Part of the problem is if you realize the issue is in the developing world, that's where the global warming will come from. Every now and then the IPCC comes out with a new measurement saying it's even worse, or you'll see newspaper headlines saying the future looks worse than it did before. People don't realize that this is because they're being less pessimistic about the future of China. China's been growing at 10% per year, not into a vacuum, but they are catching up. In this chart, by 2040, they haven't caught up. They are at half of our GDP per person. So they have a lot of room to grow into the modern economy, into the wealthy world. And I, for one, hope they will continue to grow. This assumes they grow at 10% per year, that they had a treaty where they would cut their emission intensity by 4% per year. That means their carbon growth would only be 6% per year. This is a 6% growth. So what I say here is that anything that we are doing in the United States in terms of energy efficiency, in terms of alternative energy, alternative fuels, it's got to be cheap. Because I don't think we can afford to subsidize China. And China won't do it unless it's profitable. So that's sort of one of my main bottom lines for this whole talk. But now let me back off a little bit, and I'll come back to this. And global warming, you understand, sunlight comes right in through the atmosphere. Well, some's absorbed, ignore that for now. Some's reflected, ignore that for now. The Earth heats up, emits infrared radiation. Notice it's twice as thick as that. That's the steady state, because the radiation comes up, heats up the atmosphere. The atmosphere emits up and down. This plus this equals that. You work out the numbers for this, and it says, because of the atmosphere, we are warmer by the fourth root of 2. It's a nice little physics exercise. Depends on the fact that radiation goes to the fourth power of the temperature. It's more complicated because of clouds, because not all of the infrared radiation is absorbed by the atmosphere. Some leaks through. In fact, water vapor and carbon dioxide, to the extent they increase that absorption. That increases the temperature of the atmosphere, which increases the radiation back down. In the simple picture, we're getting equal radiation from the atmosphere and from the sun. But this is the greenhouse effect, and we enhance the greenhouse effect by adding more carbon dioxide. We can't add more water, because water is determined solely by the temperature. There's so much water around that the water vapor in the atmosphere is not controlled by humans, but the carbon dioxide is. Carbon dioxide increases the temperature a little bit. That increases the water vapor a little bit. That's a positive feedback. The net temperature rise from carbon dioxide, assuming no cloud cover increase, is what is calculated. It was first calculated in 1896 by Arrhenius. Calculations were improved a few years later, again by Arrhenius. There were studies done in 1979. That's when I became interested in the subject. There was a report principal author was MacDonald, published by the National Academy. That was a major report that was inspired by Roger Revelle. The history has a long time. Now the IPCC has these enormous computer models that calculate in great detail what's going on, and lots of people say, I don't believe those because I know enormous computer models are unreliable. My reaction is, well, they are unreliable, but when they verify the back of the envelope calculation, you have some faith in both. And that's the case. The back of the envelope calculation says carbon dioxide leads to global warming. Not as much if the increase in cloud cover. There's no evidence for an increase in cloud cover. But that's somewhat uncertain. It's the biggest uncertainty right now. Okay, carbon dioxide has gone up. This is a plot without an offset zero. You usually see it with offset zeros. This shows that the carbon dioxide has recently gone up in the last 100 years, 150 years, by about 36%. According to Arrhenius, back at the turn of the previous century, that should give rise to a warming of about 0.4 degrees Celsius. What does the IPCC say we have? Well, they say the total warming has been 0.8 Celsius. The warming up until 1957, they cannot attribute to humans because it happened to follow the solar activity change. A lot of people don't realize this. It's in their report. It's in their executive summary report. They say up till 1957, it's ambiguous. We don't know whether any of the warming up until 1957 was caused by humans. But from 1957 on, most of it was caused by humans. The solar activity turned over. the carbon dioxide kept on going up. They estimate about 0.4 C due to humans, which is just what you would get from the old equations of 1979 from the McDonald report and from the updated Arrhenius calculations. So the theory is actually in very good shape, I believe. Even though people tell you can't believe these computer programs, they forget that there is a back of the envelope calculation. There's a very nice 1979 calculation, and that's sort of in agreement, and that's the cause for concern. The cause for concern in my mind is that temperatures have gone up by 0.4 Celsius. That's negligible. You can't even sense that yourself. You can measure it with thousands of thermometers around the world, and I believe it's real. Okay? I am now leading a project to get a better estimate of that number, to do a more improved analysis of the 1.6 billion temperatures in order to get a good number for that temperature increase. I don't know what I'm going to get. Maybe it will be 0.4, maybe it will be 0.6, maybe it will be 0.2. I'm not sure, but it's important. It's important not because it's big, which it isn't. It's important because it agrees with the theory. And the theory says that with a doubling of CO2, temperature will go up 2 Celsius, 2.5 Celsius, somewhere around that range. So a lot of the public thinks the problem with global warming is it's gotten so much warmer, and it hasn't. A lot of the things that are attributed to global warming are just pure nonsense, and I'll go through those. The dangerous thing is that the global warming is on track, and the theory is being verified. And if the theory is true, then in the next few years, we will get truly significant global warming. And I think we will find out, because when I showed you those curves for the developing world, no matter what we do in the United States, if we don't develop a technology that will be adopted by China, India, and the developing world, we're going to get the carbon dioxide increase. If we set an example by spending lots of money, we will be setting an example they won't follow. So, well, I'll talk more about that later. Here's the data on global warming. This is the data from the group that I had trusted most completely. Looking at all there are 3 groups that analyze the data, 2 in the United States, 1 at NOAA, 1 at NASA. And in the United States, there's this group at East Anglia that, in my evaluation at the time when I wrote my book, this was the most trustworthy group of all. And my plots always showed their data for that reason. It was also probably the one that the IPCC used the most. This is global warming. Keep in mind the following: despite the fact that Al Gore will tell you all of this is due to humans, the fact is the IPCC, there is a consensus. I call it the IPCC. When I disagree with the IPCC, I'll let you know. For the most part, I'm just explaining to you what's in there, the things that people don't notice. In their report, up till 1957, there's warming, but they don't attribute that to humans. They say, maybe it is, maybe it isn't, we don't know. But from 1957 onward, this continued to go up at a time when the solar activity leveled off and started going down. And so they attribute some or most, they have 2 different parts, one place where they say some, one place where they say most, of the warming since then, the 0.4 Celsius, was due to human activity. By the way, of that, a quarter of that is due to the US, roughly. So the US is responsible for 0.1 Celsius. Of that, how much has been contributed by our cars? That's about a quarter. So 0.025, about 0.024, it's about 1/40th of a degree Celsius has been due to our automobiles. I know a lot of you think you're fighting global warming in creating these liquids. I think what you're really fighting is energy security. I think the US contribution from automobiles is not what melted Mount Kilimanjaro. The IPCC offers 2 sets of, actually 3 arguments, 3 strong arguments that the Earth has warmed up. The second one, this is the first one. This is the one that I consider far and above the most important one. This is actual degrees Celsius, or in this case, degrees Fahrenheit. I show this to popular audiences, so my goal is not to convince them they should use Celsius. My goal is to let them know what's going on. By the way, the peak in 1998 came right before the 2001, and that, according to 2 of the 3 groups, is the warmest year we have ever had. And there was some degree of panic right after that, as people worried that this was the beginning of the great upswing with positive feedback and tipping mechanisms and all sorts of things going haywire. And it turned out it's still the highest peak ever. It was due to a particularly strong El Nino event. The other evidence that I consider strong, although it's hard to calibrate, is the sea level rise. And there's extremely good data on sea level rise. And you can see sea level has gone up by about 20 centimeters, of which 10 centimeters took place since 1957, between 5 and 10 centimeters. So sea level has gone up 2 to 4 inches due to humans. Now, you will see movies, An Inconvenient Truth, one of the movies I just can't bear to watch, shows sea level rising 30 feet. And you need to recognize when you watch a movie made by a politician, he will correctly say in the beginning there is a scientific consensus. And then you can fall into the logical trap of believing that the rest of what he says is that scientific consensus. But there's no reason for him to do that when his goal is to get you to be active in this field, to get you to do something and rise up. And so he's very careful in that movie. Not one single thing he says is false. But you get the impression when he shows the flooding that this is the consensus prediction, and it isn't. He refers to the science advisor in the UK who issued this report saying that this would happen. If you look at that report, the sea level rise that he's showing takes place in the next 1,000 years, not in the next 100 years. He forgets to mention that. So the sea level rise that's predicted by the IPCC, assuming the worst case scenario, is going to be 2 to 3 feet, not 30 feet. That's the worst case scenario. That's the consensus. That's not what Tom Friedman will tell you. Because these guys don't tell you the consensus. You got to look at the IPCC report and see what it says. Okay, now, part of the reason for confusion in this field is there are advocates, such as Al Gore and Tom Friedman, who recklessly exaggerate the data in order to get you to work on this field. And the problem with that, and I wrote an article complaining about this back in 2004, saying the difficulty with this is that years pass, 6 years have passed, and people are beginning to wonder why what was predicted isn't happening. And then they begin to learn that what Al Gore was saying was not part of the IPCC consensus, and then they feel tricked and fooled. And I fear this is happening in the United States right now. The problem is every bit as urgent as it ever was, but people who excited people by exaggerating, by saying Hurricane Katrina was due to global warming, which it wasn't, by the way, that this gets people to action, and then they learn that they were tricked. And I fear that part of the disinterest in the United States now, the fact that global warming is not considered so important, is in part because they were inspired to be interested in this by exaggerations. Anyway, here's a bunch of the problems. I don't have time to go through all this now. I'll mention some more of them. There's misinformation about global warming. The cloud effect is the newspapers, alarmists. The deniers are the people who deny global warming and pay no attention to the science. I separate them from the skeptics. Many skeptics are really very good scientists. But the deniers, and then the alarmists like Gore and Friedman, who also don't actually give you the science. And the debate is between them and who's right and who's wrong. And the alarmists show that the deniers are wrong, which they are. The deniers show that the alarmists are wrong, which they are. And the public gets really confused. And in the middle, there's actually a lot of good science going on. So, but that doesn't get to the newspaper headlines. So that's a problem. I'm going to cover through some of these issues, and I don't want to take too much time going over them right now. The biggest uncertainty in the prediction is cloud cover. Double the CO2 and increase cloud cover by 2%, and there will be no warming. I don't think anybody disagrees with that. The issue is whether cloud cover will increase. And the IPCC believes the cloud cover will not increase, but that is the biggest uncertainty in their calculation. And when they say there's a 90% chance that global warming is caused by humans, that's their number, by the way, 90% chance. Global, not 100%, not clear and incontrovertible, 90% chance, that's in the report. When they say that, The reason there's a 10% uncertainty is because of the uncertainty in cloud cover. You can look at their chart. They have a whole bunch of all the different uncertainties, and you can see that all the uncertainties are unimportant except for the cloud cover. When it warms up a little bit, you get more evaporation of water. Water increases the greenhouse effect. That's how you get the calculation. Does that water increase cloud cover? Probably not, but they're not sure. And that's the biggest uncertainty. You can find the chart in the IPCC report. Let's focus in on the last 13 years. I plot this up every month. Here's the temperature of the last 13 years, somewhat expanded scale. So there's 1 degree Fahrenheit, ½ degree Celsius. And you see the temperature by the 3 different groups that do it just hasn't changed over 13 years. Now, Jim Hansen at NASA claims, oh yes, this is the warmest year ever right there. And his data, his analysis of the data shows a warming trend that's higher than the other 2 groups show. And that can be tracked down to the way he handles 2% of the globe. He includes in the Arctic in a way different from everybody else. And by including in the Arctic, which has had warming, in a different way, he winds up showing that global warming is still going up, although at a very low pace. But the main thing is there really hasn't been significant global warming, no matter whose analysis you use, in the last 13 years. And this bothers some people. You look at the plot, and you see there are other periods in the past when it hasn't been significant. It's the trend that's important, not the last 13 years. But there's a danger that if this continues on, I suspect the reason it's not going up is because of low solar activity. And that's a temporary situation. When the solar activity comes back, we may be in for a very rapid rise in global warming. That's my best guess right now. But maybe the cloud cover is kicking in, and global warming has kind of leveled off. And that's what we need to pray for. Because I don't believe our politicians and diplomats are going to sign a treaty that will do anything. That's my pessimism. I know a lot about physics and climate, don't know much about politics, so when I say things like that, you have to take it for not a professional opinion. But you've got to know that the temperature hasn't gone up. Hurricane Katrina was right around here. We'll talk more about that in a moment. What about the US? This is, sorry to switch the colors, but this is the plot the way I have it. If we're darker in here, we turn out some lights, you might be able to see it better. This is the global warming in the United States. So if you don't do the whole world, but just do the United States, the history of temperature in the United States, this is the way it is. And you can see the warmest temperature on record, 1998. Second warmest temperature on record was 1933. If you think you've sensed global warming in the United States, you have to recognize, hey, it's not much warmer than it was in the 1930s and 40s. Global warming isn't something that you sense yourself. It's something you measure scientifically. And there's one senator who claims that she can sense global warming by the fact that the airplane bounces more than it used to. I have that quote somewhere. And no, global warming is something scientists can measure, and it's real. But I'll show you a whole bunch of data the anecdotes that people love to give that just they're not science. They're good publicity. This is the increase these are the emissions of China versus the US. This is, people tell me I shouldn't talk about this because it impugns blame to China, and I don't want to do that. China is still producing much less emissions per person than the US is. And you might say, well, therefore they have the right to do it. And okay, they have the right to do it. That's sort of bad because unfortunately the CO2, the temperature rise doesn't come about by CO2 per person. It comes about by CO2. And so they have the right to increase our temperature. And I can't deny that. But it represents the problem. Oh, this is my op-ed piece that was in the Wall Street Journal with the same plot. But there's the plot again. And here what I show in 2040, by the way, somewhere around here, China is actually producing more carbon dioxide per person than we are. That will happen at their 10% growth. Their population isn't growing so fast. So at 10% growth, pretty soon they'll catch up to us. But anyway, This is, I think, the most serious problem in the field that the experts know about that doesn't get public attention because we're so desperate to get China to sign a treaty. And anything that insults them or implies that they are the cause is something I'm told is counterproductive. But it does have this message, and this is something I believe. If we don't come up with cheap green, it will simply not be adopted by the countries that are going to contribute most of the CO2. I think for something to be sustainable, it has to be profitable. And that's something we've got to keep in mind. I mean, China will adopt anything that's profitable. Energy conservation is an easy one there. We'll talk more about energy conservation in a minute. So what happened at Copenhagen? People sometimes mistakenly think that the reason we didn't have a treaty at Copenhagen is because one political party said they wouldn't sign such a treaty. Never in the history of treaties of the United States have we required that a ratification take place before the treaty is signed. You know, we did sign, Al Gore signed the Kyoto Protocol, just could never get it ratified. No, what happened at Copenhagen was that the Chinese refused to allow inspections. That I believe President Obama was prepared to sign a treaty that would allow them a 4% reduction in their emission intensity, but he required them to take inspections. This came as a surprise to me. I was convinced he would not require inspections. The Chinese claim they've already been reducing their intensity growth so that the CO2 is only growing at 6% per year. Other organizations around the world, including one in the Netherlands, claim that's not the case, that the Chinese are going up at 10% per year. So already there's a disagreement between the emissions that other countries are claiming for China and what China is claiming itself. President Obama, in his wisdom, decided they had to have inspections. And by the way, I know a lot about remote sensing, and I do not believe we can do an adequate job of measuring their emissions using remote sensing, national technical means, as they say. So this became the contentious issue, and when they refused to agree to inspections, President Obama took the courageous move, politically courageous move, of refusing to sign a treaty. And that's going to be a contentious issue in the future. Now, the IPCC has also been under a lot of attack lately. Here's just a list of the things. A newspaper in the UK sort of systematically went through and every week exposed something else where the IPCC was using popular information, popular knowledge, rather than refereed sources. Some of these are pretty bad, and a commission has just recommended to the IPCC that their next report follow their own stated standards. The problem with this is, and the IPCC correctly says, oh, look, this stuff is kind of irrelevant. Yeah, okay, we made a mistake here. Okay, the Himalayas are not going to melt in 15 years, like our report said they could. The story there, by the way, is that the report says the Himalayas could melt in 15 or 20 years, and this had big impact on China. I know people here at Berkeley who would talk to the Chinese colleagues and say, look, this is going to impact you right away. You've got to stop global warming or you won't have a water supply. They based that on the IPCC report. The IPCC report, it turns out, based that on a comment that appeared in a popular magazine from a scientist who denies he ever said it. But before that came out, Pachauri, the head of the IPCC, when he heard that when the Indian government did a study and said, this is nonsense, you've got to retract that, his reaction was to publicly state that the Indian scientists were engaging in voodoo science and that he stands by the IPCC report. He insulted not only the Indian scientists, but also the religion of voodoo, which is a valid religion. Anyway, now Pachauri has apologized when he found out there was no scientific basis for what was in the IPCC report. But it turns out, not the important things in the IPCC report, but the things that caught the public attention are the things that are nonsense. So the IPCC says, well, that's not important. We have the temperature measurements, we have the sea level rise. Right, but what caught the public attention was the loss of species in the Amazon rainforest, the melting of the Himalayas, the increase in storms. The cost will be huge. the temperature, I don't know, the coral reefs going away, and so on. And all of that stuff turned out to be non-scientific. So the problem was the things that caught the headlines from the IPCC report were not based on peer-reviewed science. The next IPCC report we all expect will be much, much better. But it may not make the headlines as much for that reason. And so this is the old problem, the same thing I said about Al Gore. You know, when you discover that the things you were worried about were not true, then you lose faith. Okay, Climategate, let me show you a few things about Climategate. They were exonerated by several committees. The committees that exonerated them said that they had misled the public, and that was bad, and they should not have done that, and they shouldn't do it again. Let me show you how they misled the public. This is the cover from the World Meteorological Organization. This is one version of the famous hockey stick. This is a plot based primarily on proxy data, but it includes some temperature data. This is what was published. I know many scientists at Berkeley who saw this thing and said, well, the public may not understand graphs, but I do. This is clear and incontrovertible. But these are not the way the data actually appeared. The data, which we finally got about because of the Climategate leaks, we finally got them, the real data. This is what the real data look like. Okay, you see the change. This is the decline in one of the proxies. Now, it's not a scientifically significant decline. There's range here is no worse than it was here or here. So it's not really scientifically a decline, but I believe anybody in this room who had published these papers would have shown this plot. And then said, but ignore this. What they did is they didn't show this plot. They didn't release the data. They wouldn't release the data. Under the Freedom of Information Act, they wouldn't release the data. The Freedom of Information Act officers, by the way, under indictment for having failed to abide by the Freedom of Information Act in the UK. What they did was they took the data from here and said, well, that decline is unphysical. We know the temperature's going up, so let's erase it, literally. Let's not show it anywhere in any of our published data. Let us instead substitute the temperature data, and we'll hook the temperature data onto the end here and get that. Now, when I found out about this, I have to confess, you know, they didn't commit a crime. They committed a scientific crime in my mind. And at this point, this was the group whose data I had shown in my books. This was the group I trusted the most. I don't know if I could read any more of their papers at this point. They committed a scientific misleading that if it happened with a colleague of mine, I would never collaborate with that person again.
So explain again, I understand the racing, but what did they do?
Oh, they then took temperature data, which is thermometers. They stuck it on, the same data onto the end of each of those three curves, so it gives you the illusion, that you have three curves going up. And then they smoothed the data so there would be no discontinuity, because that would mislead you into thinking there was a discontinuity, when in fact all it was a data change.
So they added on a false number.
No, the numbers are real. They're temperature data.
They put observations.
They put, what they did, these are all observations.
No,
These are all observations. What they did is they took away the observations that showed a decline, a pseudo decline, and they put on different observations that show an increase.
They didn't average all the data then? They took
No,
selected data?
no, they selected the data.
Ah.
They selected the data. Okay. Anyway, so that's what they did. And then they refused to release this, but we got it. Anyway, at this point, at this point, I simply cannot trust this scientific group in the UK. It's okay, we have two other groups. But this to me was something which, if my graduate student had done this, he would no longer be my graduate student. I mean, you joke about it. You say, hell, here's typical data, ha, ha, ha. Now let me show you the real data. But this was on the cover, and it influenced a huge number of people. And I just don't think that was the proper thing to do. I think the problem with Climategate is it's undermining science. There are too many people who say, well, they're humans after all. No. No, you don't do this. You don't do this. The public is losing trust in science. Anyway, enough about Climategate. Okay, is global warming clear and uncontrovertible? I think it's pretty clear in the data, although we will find out when we redo everything. But let me show you the sorts of examples that people put forth that are not related to climate change. Increase in hurricanes. Everybody knows about the increase of hurricanes. Actually, that's not true anymore. The Hurricane Center says that the hurricanes have not been increasing over the last 100 years. This is my own plot. You can make this yourself. You can look up all the hurricanes. These are the hurricanes that hit the United States. The intense ones are in red. Those are category 4 or 5. Category 3 are in blue. All of them put together are in white. The hurricanes simply have not been going up. And well, why do people say they have? Well, a few years ago, there were reports of increase in hurricanes. 2005 was the first year we ran out of letters for hurricane names. If they're not going up, why did we run out of letters in 2005? The answer is this. Look, in 1933, there were no hurricanes out at sea. In 2005, there were enough out at sea to drive us over the limit. It was an El Nino year. The intense hurricanes of that year were attributed by the climatologists to El Nino. What's the difference? The difference was we didn't have satellites, we didn't have buoys, and the ships avoided this area because it was full of hurricanes. So there is an observational bias. Okay? This has no observational bias because these are hurricanes that hit the US, and those are all reported. You don't miss a hurricane when it hits the US coast. And they have not been going up. They're going down slightly, but it's not really very significant. Okay, what about wildfires? Oh, this is tornadoes. Al Gore says they're going up. This is published every year by the US government, number of violent tornadoes in the US. There was 1 year, peak year, probably an El Nino year. But other than that, the trend has been down. Is that due to global warming? Yes, very possibly. You see, global warming could increase the storms. That's what always gets quoted. But it also could decrease the storms. That's never quoted. How could it decrease the storms? Well, global warming, in all the theories, warms the poles more than the equator. That decreases the gradient. You decrease the gradient, and you have less of a force to generate these storms. So anyway, wildfires are also going down. How come Al Gore said they're going up? I've tried to contact him. He has not responded to me. Seriously, I believe what he did is he included all hurricanes, including those that are now detected, all tornadoes, including those that are now detected by radar, ones that never touch the ground. I believe that's what he's doing. And wildfires, I know what he's doing, which is, this is US wildfires, and they've been going down. What he does is in this case, he included only wildfires that do damage. Of course, as population grows, then the people live closer to the wildfire areas. There's more. Yeah?
There's a flurry of papers talking about the extent of area burned increasing because evaporation's going up and wet season.
Right. I mean, the area has gone up.
Extra.
The area has gone up. Although some of that is very likely due to the fact that they let them burn now when they didn't used to. And you have to separate that out. I gave this because this is the number that Al Gore gives. There are lots of statistics. I call it cherry picking. You find lots of statistics, some which show bad behavior, some which show good behavior. You pick the bad ones, put them into your movie, and then it gives a misimpression. Here's an interesting one. Alaska, there's the rise in the temperature of Alaska. If you remove the arrow, you see this, which is interesting because the scientists at Fairbanks, who are deeply worried about global warming and the warming of Alaska, say that the warming all took place around 1980 and hasn't gone up since then. This isn't evidence that global warming isn't doing it. It's simply a peculiar thing that you've got to note. And in fact, I can explain this in detail. This is the data that shows the warming hasn't gone up. This is the Northern Pacific that in a paper that shows a regime change, an increase around 1979, 1980 that seems to be reflected in Alaska. But in Fairbanks, the temperature has not gone up. The average over the past 20 years is this black curve here, and here's the temperature for, I guess this was 2010. So there's misinformation about Alaska too. Alaska's supposed to be the canary, right? No, it's not the canary. Hurricane Katrina. Oh, sea level increase. There's the melting of the north. Yes, it is melting. We are losing ice in the north. What they don't tell you is that the prediction of what would happen in Antarctica is exactly opposite from the theory of global warming. So I feel the IPCC, in picking the Arctic and ignoring the Antarctic, is cherry picking. And there's a whole story I could tell you about the Antarctic. I don't have. What's that? No, I mean the whole of Antarctica. You measure the total ice coverage of Antarctica, and that's been done with satellites. And now that's opposite to what all the predictions were in 2001. So let me just skip this. Oh, this is the oil resources. I like to show this because take a look at these two. Okay, this is 5 years ago. This is now. It wasn't that anybody knew anything different. It's just that when the price of oil drops below $60 a barrel, Canada can't afford to pump it at that level. That's what it costs for the oil sands. But if we add in natural gas, then the US has lots of reserves. And I believe that the natural gas is going to turn out to be a major competitor to biofuels. There will be pressure soon to switch our automobiles over to natural gas. They produce almost as much pollution as gasoline, but they address the energy security issue. If we include in coal, then the US is the Saudi Arabia of fossil fuels. These are all in equal units. So these are barrels of oil equivalent. We have huge amounts of coal. They have local environmental problems, but we have huge amounts of coal, and coal can be converted into liquid fuel, as I'm sure you know. This is if you include the shale oil, but nobody's going to do shale oil because the coal is so cheap. So, I mean, the US just blows away the rest of the world in terms of fossil fuel, which puts enormous economic pressure on the US to go to fossil fuel. Okay, so what are the alternative energies? Whoops, let me go here. So we need liquid energy solution. The two obvious ones are conservation and biofuels, but I think natural gas is going to play a major role. And then there's the possibility of synthetic fuels, which is environmentally bad, but provides security. And by the way, security is not just an issue in the United States, it's all around the world. So Europe now is in a panic because Russia cut off its gas for a day. And it was a stupid mistake by Russia because it let Europe know that Russia could do that. And so they're desperately trying to find other sources of energy. I mean, theoretically they could do it, but the fact that they might actually do it didn't hit the public, and now it has. So there's energy security all around the world is becoming a big issue. Look at Iran. They want nuclear reactors, and we say, oh, look, you can trust us, trust Russia. We will give you the nuclear fuel whenever you need it, and then you give it back to us. And Iran, who I don't trust for one moment, has a valid argument. They say, yeah, sure, we can trust you. You're not going to use that for political leverage someday when you don't like what we're doing. They have an energy security issue. Right now they have abundant oil, and they can make enormous money by selling it elsewhere instead of giving it to their people. So they want nuclear to run for their people. They also want to make a bomb. But the fact is, it's hard to counter them because they have a valid argument. Okay, so India, China, and the developing world. I spoke a little bit about that. The good news is that they're very inefficient. So if we look at China and we ask how much pollution they make per dollar, it's way up there compared to the US. So there is in potential a lot that they can reduce. Now right now a lot of that is coming about because they are industrializing. And there's some hope that that will come down. I mean, we are so much better than them because we're basically a service economy and no longer industrializing. But here's Russia and here's India. The bad news is the countries that are really developing rapidly, China, India, and Russia, that we expect to develop, have lots of coal. Okay, so I'm a real fan of conservation. I should wind up because I want to have time here for questions. Conservation, I'm a disciple of Art Rosenfeld. This is a photograph I took, you can't see it here. I took this in Notre Dame de Paris, and the picture actually shows chandeliers, but they don't have candles in them. They have compact fluorescent lights now in Notre Dame de Paris. So I took a picture and gave him a print of that as a present because he was largely responsible for that. Conservation is a real winner, the McKinsey analysis. I'm just going to run through the rest of these slides so we have time for questions. The cost of energy, unfortunately, coal is dirt cheap. And for the same energy, it's much cheaper than gasoline. Electric cars boy, I get more people attacking me because I don't like electric cars. But the Tesla Roadster is enormously expensive per mile when you recognize that the batteries will only last 100,000 miles and you have to replace them. And the weight of the car, this little Tesla Roadster, I don't know how many of you have seen one, it has 1,100 pounds of lithium-ion batteries in it, which if you bought retail would cost you $130,000. But they will replace them, they claim, at 40,000. So if they replace them at 40,000, if they're still in business when you need the batteries replaced, I believe they're subsidizing that 40,000. I think those batteries are costing them a lot more than that. So the cost per mile is huge when you include the battery replacement. This is what nobody ever mentions. Consumer Reports did a nice study on this. They say you can convert your hybrid to an all-electric hybrid, but then you have to replace the batteries every 3 years. And that'll cost you $20,000. But in the meantime, you'd save $3,000 in gasoline. And they actually have this in their report. And yet people are still switching to plug-in hybrids. They're ignoring the battery cost. Plug-in hybrids make no sense. Okay. Oh, there's my picture of the Tesla. Biofuels. You know this stuff much better than I do. The trouble we're having with biofuels is everybody in a panic for global warming. They say, you guys at EBI, you're not going to be ready in time. Why are we supporting you? Well, I don't know. Maybe you hear that. I don't know. Why, when what you're doing is a long-term solution? It's important to know whether whether we have the time. This is why it's really important to remeasure the temperatures, which is what we are doing. Now, not remeasuring them, but reanalyzing them, because we need to know how much time we have. I'm hoping the answer will turn out that we didn't have 0.4 degrees Celsius, we had 0.3. And that'll give us another decade and give you guys plenty more time. Wind turbines those pictures are to scale. They make them big and they put them up high because anybody who's flown a kite knows that's where the wind is. This is the growth in wind turbines. Wind power in the United States growing very, very rapidly. Solar cells I'm really enthusiastic about because the price has been plummeting. I'm not a real fan of solar thermal because the price of that isn't going down. It's just being subsidized. But the solar cells, the price is getting amazingly low. I can tell you more about that. Clean coal means carbon capture and sequestration. There's the IGCC plant. Geothermal, I'm not a fan of geothermal. Compared to the midday sun, the energy coming up from the earth is 10,000 times smaller. That means it will make monetary sense if your equipment underground is 10,000 times less expensive than the solar cells. I don't think that's going to happen. So I could talk a lot about geothermal. I'm a fan of nuclear. This doesn't address liquid energy security, but the public attitude has changed. The cost is going down. The waste issue, I think, is solved technically, but is not understood by the public, and it has Harry Reid opposing it, which is causing political problems. I've analyzed nuclear waste. Just going through these quickly, the fact is most of the nuclear waste is gone after 120 years. Lots of future energy technologies. I just want to finish up so I can get to questions. It will come from global warming will come from the developing world, unfortunately. Not good enough to set an example if the developing countries can't afford to follow that example. The green bickering in which people say, oh, we should do this, not that. I don't like solar, I don't like compact fluorescence. We need light emitting diodes and so on. It's just all counterproductive. We need everything we can get. I call that cleaner than thou pontificating. Anyway, to be sustainable, alternative energy must be profitable. And these are the things I've been saying. Global warming is real. It's due in part to humans. You haven't experienced it. The public debate is between the exaggerators and the deniers. And that means the public is not informed either. Energy security, liquid energy security is urgent and important. The alternative is going to be natural gas. Obviously, that energy conservation can help a lot in biofuels. And with that, let me open to questions. Thank you very much. Sorry for the rush at the end. Yeah.
Is that a 2% increase in
cloud cover?
2% of the present existing clouds, or 2% additional surface area?
That's 2% additional surface area.
2% additional surface
Well, wait, no, let me check on that. I haven't looked at that for a while. I think, I mean, this cloud cover now is something like 30%. And I believe this is an increase to about 31%. I worked out the numbers myself, so he says that's about right. So let's just accept that. Go ahead.
2% more surface area in total.
That's right.
So it's much more difficult for, because if it's just 2% more cloud cover, I think it's space of clouds.
Yeah, not so easy. The Earth is big. But there are clouds, people have looked at cloud seeding. There's something called geoengineering, which is something I actually know quite a bit about and which I am deeply opposed to. And that is, if it's going to warm up, then let's do something. Let's spread white things around. Let's foam up the oceans. There are a bunch of other things you can do. We can put sulfur dioxide high into the atmosphere. And there, Nathan Morrow says, and you don't have to worry about it, it'll work. Even if we solve the warming issue, assuming that's a problem, we still have a growing acidification of the oceans coming from the CO2. So, and none of the geoengineering really addresses that. And geoengineering, we don't understand the atmosphere enough for me to believe that we can play with it and make another big change. We're making one big change, CO2. The real solution is keep the carbon underground. Yes?
So I thought this was a good overview, but one of the questions I have in what you're saying is it's all in aggregate form, and decomposing this region by region, you will see substantiated warming. For example, if you look at the 1934 warming in the northern hemisphere, it was only in the northern hemisphere. All the instrumentation points to that. And if you look at the 1998 El Nino-induced warming that we see, it's anomalously warm, but it's also in the northern and southern hemisphere based on instruments. So region by region, there's a
You're talking about the actual measurements for which we have good data. That, I agree.
for which we have good data.
That's right.
As well as
In fact, there's been no global warming in the southeast U.S.
a factor of 5
None whatsoever.
warming rate in the West Antarctic as well as parts of the Arctic. These are fairly well.
Well, again, you have to be really careful not to cherry pick. Because, as I said, in the southeast United States, there's been no global warming whatsoever. And the use of precipitation, you find the precipitation in the Antarctica was exactly the opposite of what the global warming models predicted. So you want to be careful. Yes, you can say this happens and this happens and this happens, but to attribute them to global warming is you have to be careful.
I think the take-home message is that region by region, you'll see very different kinds of climatologies and very different kinds of responses to Arrhenius's law.
That's right.
In fact.
That's right. Absolutely right.
And that's really the bigger take-home statement here is that we do have a law that we're living by with the relationship of CO2 emissions in the atmosphere, and we do see a response, but the response we're not seeing in aggregate form in a very...
No. I would disagree. We see it only in the aggregate form. The local uncertainties in the theory. I mean, you say, hey, there's warming here and there's warming here. But if the aggregate shows less warming, that shows there's cooling there and there's cooling there.
Right.
And so you can't attribute this warming to global warming and say this cooling, that's irrelevant. The aggregate is the best number we have right now. And that shows 0.4 Celsius due to humans. To divide it up into regions is a very tricky thing to do. Yeah?
Would you comment on T. Boone Pickens' plan?
Well, the only trouble with T. Boone Pickens' plan is he's a billionaire. And so nobody wants him to make more money. But he's right. We should be switching over. The U.S. needs to be creating a grid so we can get wind power from the Midwest. He's right on everything that I've seen him say. But nobody wants him to make more money. And that's his problem. If he... Anyway,
He doesn't mix in nuclear.
No, I don't think, yeah. No, I mean, if he were the president of the United States, which he would like to be, then he would probably mix in nuclear and so on. But all he's trying to do is push one scheme. And boy, if he mixed in nuclear, he would get all sorts of opposition from people that he doesn't get opposition from. So there are tricky issues there. So, yeah.
So as far as the ecology and human society are concerned, I think we're probably
Yeah.
in overall, a long-term
Okay.
of temperature rise. So do you see any data indicating that is increasing?
I have not been able to find any data indicating that that's increasing, that the variability is increasing. It has, as far as I know, never been quantified as a prediction and hasn't been verified in any scientific way. So it's one of these things that it's sort of they say the variability might increase. Well, it also might decrease. And it's not a hard prediction of the IPCC that it will increase, and they don't state what it is, and they don't give, you can give examples, and then every time you see a variation, you can attribute it to that, but that's not science. So I would love to see a hard scientific analysis that shows that variability has gone up or gone down. I don't know which it has. People tend to notice variability. And so anytime it's extra cold in California or extra hot on the East Coast, like this last summer, people notice that, and then they recall that one of the possibilities is that variability would increase, and they attribute it to global warming. And that's not science. Yeah.
So some of the other gases that are involved in temperature are things like methane.
Right.
And so there are reports in the literature about this notion that there are very large amounts of methane stored in soil that
Oh, yeah.
could be released
That's
in
right.
somewhat unpredictable ways.
Yeah, that's one of the tipping points. They're particularly worried about the permafrost up in the Arctic. That's something I looked into. I talked to the Arctic scientists up there. There's been a series of tipping points. One was the disruption of the thermohaline circulation from melting water. There's others that simply say the growing ice, reduced ice caused more absorption. So there have been a series, I could probably think of 3 or 4 other so-called tipping points. In each one of those, the tipping point makes headlines, and then within a year or two, the scientists agree it's not a danger. That's the case with most of the methane in the Arctic. That is, the methane from the permafrost is actually very deep, has been leaking for many years, and is not being affected by the melting of the permafrost. However, there is methane clathrates underneath the Arctic Ocean, which if the Arctic Ocean ever warms above 4 degrees Celsius at the bottom, then we're really in deep trouble, because that would be a tipping point. Nobody foresees that much warming in the next 100 years, but it's something to really worry about. What's scary about the tipping points is not that any of them have really survived scrutiny, but that people keep on coming up with new ones. And the methane is the biggest danger because it has enormous greenhouse, because there's an enormous amount of methane around, especially in the clathrates, and it has this enormous greenhouse effectiveness. Okay, question here? Yeah.
Yeah, I just want to go back to the line of questioning that Norm was talking about, because I'm wondering whether you've heard anything about whether there's evidence that the benefits from the places where there's cooling would somehow offset the costs in the places where there's warming, or whether it's an asymmetric function.
Well, I'm not even sure that global warming leads to, the models indicate that there are certain, they all predict the models. The models all predict that there'll be regions that warm more than others. But at that level, I don't actually trust the models. I think the models are pretty good for getting the general overall magnitude. But something that they don't usually admit is that none of these models are stable. That is, the longer you run them, the more they show. And so they cut them off after a while. And this is one of the reasons people say the model's cheap. My reaction is, well, all this shows is that you can't do, the models predicted the wrong effect for Antarctica. They predicted the right effect for the Arctic. They get it right here and wrong there. And that means, in my mind, the models are not trustworthy when you get down to continent-sized regions. They're only moderately trustworthy when you're talking about the total global effect. So if global warming leads to some regions getting hot and others getting cold, if that is really true, and there's no evidence for that, then undoubtedly some areas will benefit and some will get worse. If you go up to Canada, you will see there are people who actually put on bumper stickers that say, in favor of global warming. Canadian in favor of global warming. I wouldn't mind Berkeley getting a little bit warmer myself. Yeah?
So there's a big field in quasi-geostrophic theory that will indicate that there's a redistribution in the energetics that does lead to certain types of warming and cooling. But whether it's a direct correlation to increased CO2, that remains. And that may be what you're arguing, but there's a lot of evidence that does indicate trends in that.
You're saying there's a lot of evidence that
Okay.
increased
observations showing trends of both warming and cooling in response to atmospheric dynamic shifts?
Sure, but the atmosphere has so many dynamic shifts. I mean, there's the Northern Pacific Oscillation, there's the Northern Atlantic Oscillation, there's the Northern Atlantic Decadal Oscillation, there's ENSO. All these things are going on. There are all sorts of shifts going on. To untangle that from the 0.4 Celsius of global warming is the challenge.
Right. So intermediate models can help to unravel some of this on the aggregate.
Oh, I agree. No, you learn a lot from the models. Because you learn about the mechanisms that are important. Yeah.
What's going on with pebble reactors? It seems like there's a lot of advantages.
Actually, there are many advantages to pebble beds. There are a whole new class of reactors, intermediate-sized reactors, 250 megawatt reactors that some of the companies are pushing. They're sensing that the public is now less anti-nuclear than it used to be. They also believe that Harry Reid is going to lose this issue about storing nuclear waste in Nevada because there are 31 states that have nuclear waste and they want to get rid of it and they can outvote him. So there's a positive feeling also in the Obama administration about the future of nuclear. The main problem is for nuclear, most of the money you invest is up front. And then the fuel costs nothing. The difficulty there is you got to put that big money up front for an uncertain energy costs and so on. But with the smaller reactors, it's a smaller investment. So 250 megawatts is a much smaller investment. And so they're all much more intrinsically safe, as are the pebble bed reactors. So I think we may be soon experiencing a nuclear renaissance. Certainly the rest of the world, even if the United States decides not to go along. They're developing pebble bed reactors in China. And of course, they have been developed in South Africa. So, yes?
So we've got global warming. It's due to carbon dioxide emissions and some other things. And clearly, there's a need to change energy technology. What I couldn't quite get from your talk was exactly how should you compare different energy technologies. I saw a lot of dollar figures being used to compare, but can you talk a little bit more about how you would compare different energy technologies, line them up, and say, okay, this looks like the good one, this looks like not so good?
Well, my bottom line is always that the cheaper is the better. The carbon dioxide is, there are two issues, energy security and carbon dioxide, and you have to make your own evaluation of the relative importance of those. But then, if your issue is carbon dioxide, I'd evaluate them completely on whether they will be adopted and useful in the developing world where most of the carbon dioxide is coming from. If your issue is energy security, I'm more concerned about the US than I am about Iranian energy security. And there, I think part of the issue there is how readily adoptable they will be in the United States. We know we could switch to biofuels with very little change in the automobile. Same is true of natural gas. But I rank batteries so low because the public just doesn't appreciate how expensive they are. Anyway, it's a complex question. So it's not easy to just make a ranking. And you need to recognize that batteries are very expensive and coal is very cheap and everything else is in between. And you're fighting, in many cases, against coal as the alternative. But coal converted to liquid is hard. You don't like to shovel coal into your automobile. That doesn't work so well. It has ashes. When you're finished, you got to shovel them back out. Coal doesn't work so well. But you can convert coal to liquids, particularly to diesel, is easy to do. It just costs money, probably $50 to $60 a barrel equivalent. So anyway, complex answer to a complex question.
Well, just to follow up on that, if you put nuclear pretty high,
I put nuclear pretty high, yeah.
But
it doesn't help your automobile.
well, unless you go for electric automobiles.
But that's too expensive, yeah.
But the recent history of the nuclear industry has been, at least in the West, including the French, they have a very hard time staying on budget, on time to get these things in, and they're very expensive.
They've gotten much better just in the last 20 years. The efficiency of these plants, the time, what do they call that? The load factor has gone up to 90%.
Yeah.
That's amazing.
But the French construction of the Finnish reactor at Olkiluoto is you know, Arabia apparently is having a very hard time
Yeah.
controlling the costs.
Yeah,
and,
yeah. No, I'm still seeing issues with that. I'm seeing numbers of, but Babcock and Wilcox claims to be addressing that with these smaller reactors. But I'm still seeing numbers of $5 to $10 per installed watt for nuclear power, whereas for solar it's getting down below $1 per installed watt. So nuclear is going to have a financially hard time. I agree.
Well, and certainly.
What fraction of that costs due to regulation of this kind of thing versus actual technical issues?
Yeah, that's always an interesting question. You probably know the answer as well as I do, a large part of it. And so it requires the public to recognize that the dangers of alternative fuels are very high, and you shouldn't particularly tax nuclear compared to, let's say, coal. There's a question back there? Yeah.
I was kind of curious about one of the things you did mention people attribute global warming a lot. That would be the shrinking of non-polar glaciers.
Oh yeah, the shrinking of glaciers around the world. I think. I mean, I don't have any good explanation for that other than global warming. On the other hand, if they're shrinking at the equator, you have to recognize global warming has very little effect at the equator. There's not much warming, so Kilimanjaro is not due to that. Kilimanjaro is very likely due to farming procedures in the vicinity of Kilimanjaro. But in the Andes and so on, there are shrinking glaciers. But again, you have to be careful because you got to be careful not to cherry pick too much. Yeah.
I guess the last question.
Okay, last question.
So it seems like you're advocating moderating the discussion, so bringing people into the middle.
Yeah, I guess so.
My concern with that is that sort of like the median or the mean prediction of these models might not be a big deal, but there is sort of a long tail towards the positive end of, or high end of degree C.
You're saying the worst case situation.
Yeah, it seems to me that like that's a lot, a bigger problem.
Yeah.
That's what we should.
My general feeling on that is you have to treat the public as maybe more intelligent than they are. I tend to think they are more intelligent than most people think they are, and to recognize that. But I think as a scientist, if you decide that they're going to misinterpret the tales and not recognize how dangerous they are, then and therefore you spin what you're saying to them, that you in the long term might undermine their faith in you as a scientist. And I think the irony is that we draw back from science when the problem gets really important. And yet that's when we need it the most.
Sorry about that. We'll,
Okay.
Give around